Hi, good afternoon. Welcome to Zahn Academy. My name is Erica. I'm working with the education team and I'm standing in for Fran today. Today's webinar is Fabrication of Metal-Free Removable Partial Dentures and Flippers featuring Myerson materials. Our presenter today is Kris Schermerhorn. He is a CDT and also the owner of Northern Virginia Dental Lab. Kris will be taking questions at the end of his presentation, so please feel free to type them in to the question and answer button or the chat. Thank you so much and welcome, Kris.
Great, thanks a lot. So yeah, what we're going to talk about today is the different materials that Myerson offers. Mostly 90% of what I'm going to talk about today is going to involve digitally design and milling. We'll go into repairing, which is more of an analog, of course, hands-on process, and we'll talk a small amount about printing. You know, it seems that printing is the the big push nowadays, but there's still room for milling. There's just some materials that have certain properties that you just can't get with 3D printing yet. And so, we're going to kind of go through design with 3Shape as well as Exocad, because I know we can have a mixture of people as far as softwares they use. We'll talk about milling machines specifically. I'm going to go into the Roland DC53. It's their newest mill. It's been kind of geared for plastics, and kind of talk about how I go about nesting and just some of the advantages that machine that I found has. And then we'll talk about producing your teeth, whether by milling, and then I'll talk a little bit about 3D printing at that point. And then we'll talk about repairing, because we always need to have the ability to possibly repair our removable appliances. So materials we're going to talk about is Duraflex. So Duraflex is a flexible material. You can make your typical flexi, all right, so pink base clasps with your teeth in sockets, or you could do a framework type of design. I'm going to kind of talk about both today. We're going to also talk about the VisiClear. VisiClear is the same exact material, or almost exact material, as the Duraflex, just doesn't have pink in it. And it's kind of a mostly clear, kind of a hazy clear. And I'll talk about why that's not such a bad thing as far as aesthetics are concerned. And we're going to talk about the acetal. That's the Zerlux acetal towards the end. But right now we're going to kind of head down the road of the more flexible option, which is the Duraflex and VisiClear. One thing to understand about Myerson's materials that they have to offer, whether it be Trusana and their 3D printable material, or their Duraflex, Duracetal, Zerlux acetal, Duraflex, VisiClear, all their different materials, they want to make sure that it doesn't absorb moisture, or if it does, it's just a microscopic amount. There's been a lot of materials that have come out that are still being created for 3D printing that just draw moisture in. And that's just not a good thing for in the mouth. The mouth is a high moisture environment, of course. With moisture comes stains, bacteria, and smells. And so you'll find on their thermoplastic range, which is the Duraflex, the VisiClear, as well as the Zerlux acetal, they're all crystalline plastics. And crystalline plastics tend to have a dense structure. The way that other materials can be flexible is they have gaps and spaces between the molecules. And those gaps and spaces are like bubbles that when you flex it, those bubbles squish, and that's why it can flex. The problem with those bubbles are they allow moisture in. Matter of fact, they'll pull moisture in for some materials. With Myerson's products being crystalline, that crystalline structure is what allows the material to be flexible at the same time as almost 100% dense. So that's in everything that Myerson tries to produce, that's one big focal point that they have, because they know that that's one, property you have to have a successful appliance. So you can see here, other leading flexible materials that were tested in our industry, so over a 24-hour period, had absorbed 1.30% liquid. And that was only over 24 hours. It was still going at that point. So we didn't see how far it could actually go as far as absorption, but that's already just way too much. You can see here with the Duraflex, it was 0.05, which is just, as close to nothing as you can get almost. Can't really see it in this slide so great, but we did testing with a leading brand to our Duraflex, and you can see here soaked in these different liquids that would normally be something that would stain the Duraflex. Because it doesn't absorb anything, it was kind of a moot point, but it just didn't absorb any moisture. Whereas with the other materials, they dramatically got darker. Again, it doesn't really show in this slide too great, but it only makes sense. If you're absorbing that moisture, you're going to take on the particles from these materials that are going to stain. So that's a little bit about the materials that I'm going to show producing. I mean, it's always important. I can show you how to digitally design something, but if you can't produce a long-lasting material, kind of what good is a good design? So I'm going to show first 3Shape, and then we'll move to Exocad. I think one of the most popular questions that I get is undercut. It's tricky because with cast partial frames, metal, there's really very little movement, right? Very little flex. The last 10% usually of a clasp is in the undercut. The rest of the clasp is at or above the height of contour of that tooth, or the undercut of that tooth. And it's really, cast partial frames kind of wedge themselves into place. Whereas a flexible partial, the clasp flexes out over and drops into, in a lot of instances, a very deep undercut. So, it's hard to say, hey, go, a half a millimeter into an undercut, or a certain degree, like you would with metal, into an undercut, because a tooth could change so much over, a millimeter or two distance. So one thing that's nice about design softwares is they kind of show you the intensity of the undercut by colors. So with 3Shape, it's kind of red to orange to yellow, and yellow being your least amount of undercut, and your red being your most extreme. I would say, with a flexible, the most the problem you're going to get when it comes to undercuts is more of the path of insertion of the partial, rather than the individual undercut of a tooth and where that clasp goes. A flexible clasp will probably go into most undercuts on an individual tooth. But if you have two canines that are leaning like this, and now you have a partial that you're trying to have a path of insertion with, that's where the problem becomes. I don't care how flexible those clasps are. If those canines are leaning, you're not going to be able to get it to place. So that's been the real advantage to digitally designing that I've seen over your traditional processing of a flexible, is being able to see and create a path of insertion that works for that partial to go in and out. So when it comes to an undercut, I would say that the tip of the clasp could go into the red, the deep red, and I think it would be fine. It's where that clasp comes around the tooth that's going to be your concern, because either you're going to be going into the major connector or the flange if it's more of your socket kind of typical flexi, or if you're doing a framework, you're going to have acrylic on there eventually, which is going to keep that clasp from flexing at that point. And so that's where your path of insertion. So you want the clasp to be at or above the height of contour, and then it can go into that deep undercut, and you'll have a lot of movement of that clasp and probably not have any issues with it going into place. You can also, with a flexible partial, expose some lingual retention. The lingual retention is something you really can't utilize with a metal frame because, of course, there's no movement of that, so there would be no engaging or making its way even into place without scraping teeth or doing something like that. With a flexible, of course, that major connector can. So, there's been several times where I've had almost zero retention on the facial of teeth, but a lot of retention on the lingual. And I'll expose that lingual retention and then run clasps. And really, the clasps on the facial become my reciprocating clasp, right? The clasp that holds the tooth from orthodontically moving. So don't, whenever you're digitally designing, or if you're traditionally doing a case analog, don't limit yourself. Go ahead and expose some undercut on the lingual if it's needed. So with the software, if we have anybody who's really not done any design in the software, I like, you can set it to show you a degree of undercut from the get-go, but I like it to just block out straight from the undercut down, like kind of a 0 degree, just undercut straight down, it blocks it out. And then you go in and I'll expose some undercut, right? And so my clasp was coming across here. I had some lingual undercut, so I really didn't need to expose, if we go back, that deep red, because I was a little close to the major connector. So I'm just going to engage a little bit of that. And as I showed you on the lingual, I exposed a little undercut there. So this is going to give me some retention, but mostly kind of some reciprocation. Once you've exposed the undercut that you want to expose, the next thing the 3Shape will ask you is to mark your mesh, right? And so we're going to mark our mesh and then create our mesh. So you can either choose a mesh that has some holes in it or some squares in it. I like the holes because you get a little more thickness in between. And, this is a flexible material, and that mesh, we don't need flex. Matter of fact, we don't want flex. We want that ridge to be pretty solid when the acrylic wraps around it. So let me not get ahead of myself. Make sure everyone understands. First, we're going to show you designing a like a framework. So it'd be like a cast partial frame, except for we'll mill it out of Zerlux Acetal or Duraflex or Visiclear. But you can also choose a solid piece here, and then you could place your holes in it where you would want your retentive holes. Kind of like that because you can control things a little better. And again, I like to have a good gap between the holes so I get some thickness, so I get some stability. Once you mark those positions and you accept and you have your mesh in place, it's then going to ask you to do your major connector. In your settings for your mesh, there is a DME floating out there, but really the DME only really changes like two things: your major connector thickness and your mesh block out and thickness. So you can kind of find that DME, or you can just go in and I just change it. So the resin gap, that's the space under the mesh, I like to put it at 0.9, almost a millimeter. Again, we don't want flex. And the more block out we have under the mesh, the more robust finish line it's going to create. And that's going to make a nice butt for the acrylic to butt up against the Duraflex or Visiclear frame. So, and it also gives a nice amount of acrylic around that mesh. So again, it keeps everything as stable. And, we want flex in certain areas and we don't want flex in others. And that's a good way of kind of accomplishing that. So the gap underneath 0.9. Then you're going to go over and the software is going to have you mark your major connector. Make sure you overlap your mesh so that you have a connection there. If ever, let's say you don't overlap and you have a gap, and let's say you have that little hole and you're like, I don't like that. One thing with 3Shape that I kind of don't like compared to Exocad is it once you create a spline, you're kind of locked into that. Now, the cool thing I like about 3Shape above Exocad is once you accept, like you designed your mesh and then you design your major connector, it kind of smooths it all together. With Exocad, you can go back and add wherever, just about at any time you'd want to. You aren't really limited to those splines, But whenever you do add your mesh and then you add your major connector, there's always kind of a humpy, kind of bumpy joint between those that you always have to smooth out. So I think probably locking you into those splines probably has something to do with the fact that it smooths everything for you nicely. I don't know, but all these softwares are great. They all have their pros and cons. It is kind of what it is. So now you have your frame, major connector, you have your mesh. Then it's going to have you mark your clasps. When it comes to the mesh, as I said, the DMEs, I like to have my major connector right at about 1 millimeter thick. And to achieve that in my settings for my major connector, if I have my substructure thickness at about 0.8 and then my wax thickness at 0.10, the wax thickness is like when you have that rugae underneath, the higher you put this number, the more it's going to smooth all that out and make it so that you don't really see the rugae showing through. If you put it at 0, it'd almost be a duplicate of what the tissue is on the outside. So default, I think, is 0.30. I move it to 0.1 because I do like to have a little of that rugae show so it feels familiar to the tongue. But if you put this up to 0.3, it's going to thicken it a little because it's going to have smoothed it. I'd bump this down to maybe 0.7 so that you still end up at about 1 millimeter. So this setting here has me end up with a major connector at or about 1 millimeter thick. Next is your clasps. You could make the clasps part of your major connector. So when you marked your major connector, you could have come around and kind of made a clasp if you're doing more of the wing type, this is more of what you're going to want for a more flexible partial material like the Duraflex or VisiClear. This up here is going to be more of like what you would want for the Zerlux acetal. It's a little bit more rigid than the Duraflex and the VisiClear. So, this one I would probably create the spline for the clasp. And if you're doing Duraflex or VisiClear, I'd probably just mark it as part of my major connector because my major connector is going to come out to be at about 1 millimeter. That means my clasp is in the very center is going to be about 1 millimeter. And that's a little heavy, but I can just go back and smooth it a little because probably, the wider you go with a clasp, the thinner you can go. So if you go fairly wide, you could probably go as thin as, 6/10, maybe 6 to 8/10 of a millimeter thick. If you crunch it up, you're going to have to get fatter. You're going to have to make it more chubby out this way so that your clasp just isn't flopping in the breeze. So cool thing about 3Shape is when you create your splines, you can hover over one of these and you can hit your shift. Well, your shift and or your control, and then roll your mouse. And I think it's the shift will make it bigger up and down, and the control will make it fatter in and out. Or you can hold both and it'll make it wider and fatter all at the same time as you roll your mouse. That's a really cool thing that 3Shape offers that I like. So yeah, this is kind of what it's going to give you once you create your spline. This is what I would like to see. You're probably in the middle here at about 1.5 millimeters wide. Here you're probably a 2 and maybe a little bit bigger, maybe 3 as it rolls into the major connector with the Zerlux acetal. This is going to be more of what you're going to look for with Duraflex VisiClear. You're probably 3 here, probably 4, and then maybe 5 or 6 as you roll in. The wider you go, the thinner you can go. So the wider here, the thinner you are. And then when you set your denture tooth in there, you don't have it, that clasp in the way as badly. Finally, you'll place your finish line. Your finish line, again, each spline you can click shift and or control or both and make it bigger this way. Again, we want a nice butt joint between the materials, so I like to make it broader here. I mean, no illusions. This is not a cast partial frame out of metal. That's going to be your most dainty, thin option. But we're not horribly thicker than that, and I think patients really like that. It doesn't have metal taste and the weight of it, believe it or not, they feel the difference. So I think it's well worth the sacrifice. And then there's your final case. You can smooth things up here and there, but like I said, 3Shape does a pretty darn good job at having things fairly well completed by the time you're done. You can also do a tissue stop at the end if you wanted to have a tissue stop on a free end. That's real easy to do at the very end. All right, moving to Exocad now. So we'll kind of see the differences, similar but different. Exocad, again, shows red as your most extreme undercut, and then goes to kind of an orange to a yellow to a green to a pale blue to a dark blue. So it has more colors to show a little bit more of a gradient of the undercut. Don't really like one more than the other, I find. Again, in this one, we're going to leave this blocked out over the height of contour, then down into the undercut. With Exocad, a little different. It'll have you mark your major connector as mesh as well as your major connector. Also, at that point, you can actually mark a spot for your tissue stop. So it'll kind of make it part of this part of the design instead of kind of adding it at the end, almost as an attachment is the way you add it with 3Shape, but it's fine. I mean, either is fine. And so you can see I engaged clasp here. If it's a nice deep rest prep, the Zerlux acetal is rigid enough that it actually does really, really well. The VisiClear and the Duraflex, I'm a little iffy on. That material is pretty flexible, and if you got to have some bulk right here so that rest just isn't flopping in the breeze. So that would be kind of up to you whether you would use a rest with those more, the VisiClear or the Duraflex. Singulum rest work really good with any of the materials because it's a broader surface and doesn't have the flex. Again, here is round. If you click that down arrow to give you a choice of square, and then what does it say? Smooth, I think, is the word that they use. And the smooth is a lot of times what I'll choose, and it'll just make a solid piece here. No holes in it, no nothing. I like it just because I can kind of control where the retentions are. But one thing that's cool about Exocad is this little arrow here, you can kind of swoop it and you can kind of turn these so that you can line them up. And then you can drag it and move it back and forth, and it'll make them bigger and smaller. So that one's kind of cool with the Exocad. But I still just choose to do a solid piece here. With the mesh, I like to have, again, about 9/10. This is 8.5, about 9/10 of the mesh thickness, and then the relief under it, again, 8 to 9/10 underneath of it. Down here, you'll have your setting of your major connector. I set that at about 1. We have a pretty broad major connector, so 1 is going to be good. If in Exocad, will kind of, I really like that it shows a lot of the rugae through, but you could always go back and smooth it. If it's a smaller major connector, I may bump that up to 1.1, maybe 1.2. And that'll kind of get you where you need to be. But you can kind of see here the bump whenever you accept through Exocad that you have to kind of smooth out. Kind of around the next of the teeth. 3Shape's a little bit more smooth there. So I usually go in and kind of smooth that out. Here's my rest. You can kind of see that it's a little, I need to kind of add a little and then smooth it. So that's kind of what you give up for being able to just, I could go to the wizard mode and just add an AP strap across here with a tool, So that's a cool thing, but you give something for that. And so once you add your finish lines, you'll have to, again, smooth those up a little bit. And there's your case. And these clasps are more of what you would have for a Zerlux acetal type thickness. So you can see they're not huge, but they also aren't the size of metal. It's definitely a thicker, material. Here's what a VisiClear would look like. Again, it has a little bit of a haze to it. It's actually a good thing. You kind of see it when it sits in the model. As the light goes through, what the haze you're seeing is that crystalline structure I talked about at the start. So once light goes through, hits a model or a tooth or tissue and bounces back, it kind of gets deflected and dispersed throughout and winds up kind of absorbing that color. So I found where a clasp is on the tissue, it turns pink. Where it's on a tooth, it turns tooth color. Whereas if you have a optically crystal clear material, it can show shadows. It kind of, where a clasp rolls into the acrylic, patients will be like, hey, I have this dirt here. I take it out to clean it. There's nothing there. What they're seeing is that clasp going back inside that acrylic. And it's like a fiber optic cable. They're seeing all the way down in there, which is this dark, area. So I definitely, you want to educate your doctors, make sure they understand what they're going to receive. But I do like, the VisiClear and that haziness rather than optically crystal clear. But you can see it looks really nice. It's just, if I was to need a partial, I think I would choose a pink Zerlux acetal framework because it's a little more stable. It has a flex enough to be comfortable, but not so flexible that you're going to get sore spots and stuff. But it's close because this is definitely the most aesthetic option, right? It is not by far, but it's going to be more aesthetic. So it's kind of like cast partial frame, Zerlux pink, Zerlux acetal pink, and then VisiClear and Duraflex are fairly neck and neck depending on the situation. So yeah, it's really kind of neck and neck. And I would say if you don't have any freehand extensions, this would be fine. Freehand extensions is where I really worry about flexibility. And that's why I like to do AP straps or strap across because, this movement back and forth is what will give the sore spots. And the AP strap can really keep that from happening. So don't be afraid to design in a AP strap, especially if there's a flat ridge here. There's a flat ridge, it's like trying to ride a horse Indian style. All right, your legs are what keeps you on the back of that horse. And that's the same with the flanges on each side is what's going to keep that partial from moving. So yeah, definitely. You can see here the aesthetics of the VisiClear, how it absorbs the color. All right, so Zerlux acetal, we kind of already talked about. Nothing too much different here, but you can see this is what I was thinking of for the more flexible options. This is more of what you're going to have when it comes to the Zerlux acetal. The clasp can be a little more dainty. You don't necessarily have to touch the tissue. You can go right down to it. It does come in it comes in bleaching shade. It comes in B1, A1, A2, A3, A3, and then a C shade. I think it's a C2, as well as the pink. So if you have to have the clasp up on the tooth, we do have tooth colors so that it's, it's still something on the tooth there, but it's, you don't want a pink clasp going across the middle of the tooth. And here's kind of a design, just a little different partial design that's done, and I'll show you that case finished and milled a little bit later on. All right, moving to, that was the framework. So when it comes to clasp design, when it comes to undercut, everything applies to the frames. It also applies to more of your socket type design, right? So your flexible base with sockets for teeth. And in 3Shape, it's a little bit of a workaround. Two things are a workaround. One is having the teeth splinted together is a little bit of a workaround to have happen as possible, but it's a little, it's a workaround. Also putting, and I'll show you in a little bit, a retentive post inside because we're still dealing with a mechanical retention. If you guys want to see a little bit more in-depth design webinar, I did one back at the end of last year. It was a two-part series. Did one at the end of last year, and then I did the second part at the beginning of this year. If you go onto Zahn's YouTube channel, everything is in chronological order. So if you scroll down to I think it was January of last year. I'm sorry. Well, it would be like November or December of last year was the first one. The second one I think was in January. And there's a design, a little bit more about design, also bonding the teeth, and it shows. But I do like splinting the teeth together, and I do like having a post for retention because it's still mechanical retention. We aren't going to be able to bond to the Duraflex. One of the great things about Duraflex is it resists adhering to stains, bacteria, and smells. It also resists adhering to just about anything else. So that's, still a challenge we have to deal with, whether it be digitally designing and producing these, or if we're doing, traditional injection, we still have to create a mechanical retention. So here's your design again. The clasp and the undercut and the engagement of that undercut is the same. So milling, we don't want to take up our mill. If you have a mill that isn't robust, right? So it doesn't have a spindle that has torque. Like with zirconia, we need a spindle that gets some RPMs. With plastics, we need torque because we want to bite a chunk off and throw it away, and bite a chunk off and throw it away. We don't want to sand it away like we do with zirconia. And with that, because we have a spindle that needs to put out a lot of torque, we also need to have a mill that's very rigid, right? So the mounting of the spindle and everything has to be really rigid because there's going to be a lot of torque on that spindle that it's putting out. And Roland has really stepped it up with their new, somewhat new. I mean, it's been out for over a year, but it's the DC53. A couple things are really nice about it. It's a puck changing mill. The milling chamber has been segregated from a lot of the other areas of the mill, so that little particles and dust and different things, it keeps the parts of the mill that need to stay clean. Also, you can't really see it on here, but there's a piece of plastic that sits in there by magnets, and then the door closes. It really is a quiet mill. Probably the loudest part of the mill is the suction unit. It's a really quiet operating mill. It mills up real high, but there's a camera in there, and I can actually log on by my phone and watch a job, milling and make sure that everything's fine. So you could even be at home and you could check in, before you go to bed and make sure that rush case that you put to mill before you left the lab is milling fine and everything's good to go. So they made this mill with a spindle that has a ton of torque, and the structure of the mill very rigid to be able to support that. So this is a design case. This is the retentive posts, that I design into my cases. And with this mill and the 3 millimeter single flute tool for bulk reduction, 2 millimeter tool, and then a 1 millimeter tool. And then depending on the intricacy of the sockets, I may go down to a 0.6 millimeter tool to do some fine tuning in those sockets. That's, from case to case. If I'm doing a framework, I really just do 3, 2, and 1. I don't really bother with the smaller sizes like the 0.8, 0.6, 0.3, definitely not. And so they have a standard bracket. They also have the open edge bracket. Now the open edge bracket, they kind of created, well, not really, but one of the big pushes for that was when you do an all-on-X case and you want to reach the facial, because a lot of times you can kind of have an undercut there, and some mills will have a hard time really getting a nice defined juncture between the tissue and the teeth on like an all zirconia or an all PMMA. So the mill can kind of reach that area much easier. It kind of has an open edge on it. The thing that I've found is it actually allows you to fit larger appliances in one puck. So you get more economical with plastics, and I'll show you that in a little bit. But there's really nothing tricky to nesting necessarily. Be wary of undercuts. Now the mill can reach it from the top and the bottom. So, and it also reaches a really nice degree of undercut. So I don't know that, most cases you aren't really going to have to worry about it, but I do try to turn and position it so that I don't have this is showing the undercut. I don't have an extreme amount of undercut around these posts as in one kind of congregated in one specific side. I'll kind of tilt things so I spread that out evenly. Also, Roland has really nice support pieces, tabs that they've developed specifically for plastics. So they're square or rectangular. And then they also have a little notch that you can have. I like to have them notched. I don't have them totally cut, but I have them notched. And it just, I mean, they'll come out of that puck just so easy. And that works out really, really smooth. Frameworks, because you don't have any facial flange as part of it, don't take up much space. I will fit at least 2. So when you're kind of figuring out the, whether this economically makes sense, the pucks are like $75, $78, depending on the thicknesses. You can kind of confirm with your Zon rep to get exact pricing. I haven't really looked at the exact pricing in a while, but it's right around there. And so you can definitely fit 2 frames in. So you're looking at, 30, 35. Now, keep in mind, I'll mill a lot of individual clasps, and they'll mill in like 10 or 15 minutes really fast. And I could stick those unilaterals, little Nesbitt's, I'll design those and stick those in the vacant spots all day long. So when I say you're getting 2 frames out of 1 puck, you can get a lot of other stuff. And I mean, this morning I did 3 frames in 1 puck. So one of the frames is a little bit smaller. So there's times where you can definitely fit 3 in there. And so, that was a 15 millimeter puck. I would say 40 to 50% of your frames will fit in a 15. When you have uppers with a deeper pallet, that's where you'll need to go to your 20. And then every once in a while, you'll need to have a 25, but it does come in 15, 20, and 25 millimeter thick pucks. So I would say if you want to not really worry about much inventory, if you go from 15 to 20, you're going to save like 10 minutes in milling time because it doesn't have that little bit of extra bulk reduction. So it's not a huge savings in time. So if you keep 20 millimeter pucks in there, you'll be in good shape for, probably 95% of your cases. Here's that open edge puck. And here's where like these are big because you have the flanges for an all, full flexible partial. But you can move this guy to the edge. Now this mill would give you an error if there was actual metal there, because of course it'd want to go out and it'd be hitting your frame. But you can move it out into that vacant space and the machine is going to be fine with it, and then just support things. And like you have this chunk here, a lot of times I'll put some supports because I didn't want this clasp to be unsupported because it'll chatter and it can get knurled if you're not careful by the machine because of the vibration. So I just put support here, and that way I have support. So they're all 3 working together to keep things rigid in that area. But you can see how this open-edged puck really helps you to fit larger cases. This would never fit in this 1 puck, so I'd have to do this one. I have to wait for a smaller partial to fit in here later on. So that's one of the things I really like about that. Now, you have the option of a 3 millimeter tool. We also have a 4 millimeter tool. The 4 millimeter tool I kind of like to just use when I have a denture, because when you use that 4 millimeter tool, you have to have an offset from your appliance that's much bigger, and therefore it uses up more space in your puck. When you're doing a denture, you're pretty much going to do 1 denture in a puck, and that's it. So having that big offset, not a big deal. And then you have, the speed you have. But both of those bulk reduction pucks, the 3 and the 4, are single flute. Single flute tooling is ideal for plastics because that, like I said, it wants to take a chunk out and throw it. When you have a single flute tool, you can take in most instances, a 75% bite, which means when it steps in and starts to mill, it can step in 75% of the tool size. So if it's a 3 millimeter, it can take, math, 2.25. Is that about right? No, it'd be 2 millimeters. So it can take a 2 millimeter bite or close to it. You take a 2 millimeter bite. If you had a dual flute tool, you can only take a 50% bite. So if you had a 3 millimeter dual flute, you would only be able to take a 1.5 millimeter bite. So when it comes to bulk reduction, single flute is ideal for plastics. And here's an example. So if you have a 3 millimeter tool, you're going to have a 4 millimeter offset, all right, this gap. If you have and you could push this, but this is ideal. If you have a 4mm tool, you want to have a 6mm offset. You might go down to 5, but you can see the difference in the offset and how much more space it eats up in that puck. So, I think the 4mm tool would be good for, from the 3 to a 4 with these plastics with a normal, you might save 10 minutes. So I don't know. It's up to you, but I don't know if that's worth it. And here's a little picture from the camera that's up in the mill showing, so you can really see what you're milling nicely with that camera. And that case I showed you earlier that was designed, this is it milled. And so you can see it really comes out of the mill almost shiny, almost, the polishing of it is quick and really not that involved. So when you do a flexible partial, like we were just showing, and you need teeth, you have two options. You have the ability to mill the teeth, which is fine. You can mill them, or you can print them. And that's totally up to you. I don't see one advantage over the other. You can see here's the retentive posts. These are printed in Trusana, these teeth. If you look close, you can see the little bumps from printing in the Asiga printer. That was right out of the printer, cleaned it and going into place. They don't always fit like that. Don't let me mislead you. I would say 80% of the time, 75 to 80% of the time, they will drop right into place like this. I would say that maybe another 10 to 15% of the time, maybe 20% of the time, close to 100% filling out, you have to do a little adjustments, right? The mill blocked out something around those posts, didn't quite mill it. Software block, just little things didn't quite go perfect. And it just had a little, you go in there, grind a little, and it drops right down. And then there's the rarity where, down in the socket, there just wasn't enough room. You broke a tool, whatever it is that you have to do a ton of work to get it to fit, or maybe you just redo it. But there's a really good success rate. My decision making in the lab right now is mostly I print the teeth, right? The Trusana has extreme wear resistance. It has nice translucency with the pucks that I mill for teeth. It has a gradient built in, but it's hard to manage that gradient. So aesthetically, in most instances, I will print the teeth in a Trusana. Now, if I have a little unilateral and it's a single tooth, I'll take it over to the mill and have it done in 10 minutes. All right, just mill out a quick tooth. I can mill out I did one yesterday. Milled out a unilateral, milled in like 25 minutes, and milled the tooth in like 10 minutes. And that case was over there getting bonded together. So, it's nice to have that flexibility. Some interesting things you can do. This patient has 3 anteriors that are fairly broken down but healthy, 2 crowns in the back. So we did a little combo case where we did kind of a snap-on smile in the anterior and prepped for acrylic and denture teeth in the posterior. This is actually injected. This wasn't milled. I did this one case years ago, but you could very easily design this, digitally, no problem. Clasps and rests on these teeth, and here it is in place. And so you can really do some neat things. This is the Zerluxacetal in a tooth color. So you can really do some cool things with these materials kind of that are outside of the box. Repairing. So, we're going to get these cases back. The hotshot gun that's made for injecting and repairing Duraflex will work on Duraflex whether it's been injected or milled. The materials are very similar to each other, almost exactly the same. There's slight differences, but the repair processes will work on each. So if you have to add a tooth, you'll just wax the tooth in place, do a putty matrix. You can see the putty matrix, you want to have a little bit of a gap lingually. You'll heat the area with this little hotshot blazer torch. You'll have the gun, the plastic melted in the hotshot gun. You'll take the torch, you'll heat the socket, and then for about 2 seconds, then bring the nozzle of the gun in and inject a blob. You'll pick up your putty matrix and you'll smash it into place, smushing that blob around, like you would with acrylic. So if you guys, again, trying to think when we did it, but if you check on Zon's YouTube channel, I have some videos actually showing repairing on there. You can do searches through there. So you'll be able to search that and kind of see it in real time. Here's what you're left with when you remove the putty. You'll always have a little flash over the adjacent teeth. Well, one thing that I'll usually do here with this blob is I'll take foil, and with a gloved hand, I'll just smash that blob. Every once in a while, I'd get a bubble in here. And I found that once I push the putty into place, then I take my finger with the foil and just kind of smash that, and that would pop any bubble and kind of force it out of there. And you'll have this flash, but it'll trim off the teeth easy. And it's funny, you'll see that line of demarcation. As you start finishing, you'll see it disappear. And that's where you got to the point where it welded or melted together. And you'll have no line of demarcation. It's as good as probably as good as new, because it's welded. It's the same material and it's all welded together. Acetal, Zerlux acetal, you can repair as well. This was a case where the impression was bad. And the doctor's like, oh, the patient gets food jammed up in here. So what I do is I wax this area ideal. I then do a putty matrix of it. I heat and inject almost like I'm caulking the shower. I heat and I just kind of follow it with a bead of material from the hot shot gun. Take my putty, smash it into place. You'll have all this excess, but it'll trim up easily. And here it is ready for polishing, adapted perfectly. So, you can never do a repair like that to metal. Or if you could, that would be a heck of a feat. So these materials are very adaptive and, very repairable. You can see before and after. So that's everything. Hopefully that gave you a big overview. And I think if you're new to these materials, definitely go onto Zon's YouTube channel and look at some of my past YouTube webinars and videos and some things. And I think you'll find that it's a really fun material to work with. So if there's any questions, you can type it into the question section or the chat section or the question and answer section, and we'll be able to read that and answer those questions. If you're, you don't have any questions now, but you develop some, or you really don't want to do that on here, you can contact your Zon representative in your area, and if they can answer your question, they'll get you in contact with me or somebody from Myerson that will definitely be able to, answer that question.
Now, Kris, I don't see any questions at the moment.
Okay.
But like Kris said, feel free to reach out to your Zon representative.
Yep. And like I said, I think one thing that's surprising is that Zon YouTube channel. They usually put out a few webinars or videos a month on there. And I mean, it's everything from implants to all-on-4s to 3D printing to milling. And there's a lot of Myerson on there. Even the Snap-on Smile that we kind of showed that case that was a little combo, that's on there. There's videos on there how to go about that. So definitely check out those. Utilize that YouTube channel because it's full of a lot of good information.
Terrific. Well, thank you so much, Kris, for another great presentation. Lots of great information. And like Kris said, if you have any questions, feel free to reach out to your representative. And you can also message us. Coming up next week on Wednesday, we will have on December 20th, course on designing premium dentures in 3-shade. And that's when you'll get to see and follow along with a live design session. So feel free to tune in. Registration is happening right now. Go to Zon Academy, sign up, get those credits. And we'd love to see you next week. And have a great rest of the day. Thank you, Kris.